Dear- In this video, we are going to discuss resonant antenna and not resonant antenna. What is resonant antenna and non-resonant antenna? We will list out the differences between resonant antenna and non-resonant antenna. Okay, so let's see here. Let us here. I will discuss regarding resonant antenna. Here I will discuss regarding non-resonant antenna. So this resonant antennas, they are also called as standing wave antennas. They are also called as standing wave antennas. Standing wave. Here, non-resonant antenna, they are also called as traveling wave antennas. Traveling wave antennas. They are called as traveling wave antennas. Okay. So we'll see what is meant by this standing wave and traveling. Okay. So now I will draw the diagram. So for example, let us consider. So this is my feed point. This is my feed point. Okay. So feed point means here I am providing input. Okay. So whatever the input I have provided here. Okay. So that it goes like this. Okay. So if there is any impedance mismatch, if there is any impedance mismatch, automatically due to impedance mismatch, some of the signal what we have transmitted will again reflected back. Okay. So in this thick one, this indicates incident signal and the signal due to impedance mismatch. Okay, due to impedance mismatch, the signal, whatever the signal it has came, so this is reflected or standing. It is called as reflected or standing. Okay, so in a resonant antenna, due to impedance mismatch, we will get incident wave along with that standing wave. But whereas in the non-resonant antenna, so I'll draw the same diagram here. Whereas in non-resonant antenna, let us consider this is the feed point. Okay, so this is my feed point. This is my feed point. Okay, so here in non-resonant antenna, at the output side, termination is provided. Termination provided. So due to this impedance of the characteristic impedance of the antenna here, that is not available in the resonant antenna, whereas in non-resonant antenna, characteristic impedance is provided. Due to this, the mismatch is very, very less. So whatever the signal you have transmitted, that signal simply travels without reflecting back. Whatever the signal you have transmitted. So this is called as traveling wave. Okay, so whatever the signal you have transmitted, it will not get reflected because you are providing impedance matching, like stub matching we are providing here. So there will be no reflection. Okay, so third thing. So in resonant antenna, for example, this is our resonant antenna, we will get bidirectional pattern. We will get bidirectional pattern. Means generally all our radiation should be unidirectional, but in resonant antenna we will get bidirectional. Means most of the energy is getting wasted. Okay, so both the front direction as well as back direction will get. Here the radiation pattern is bidirectional, which is not desirable. Whereas coming to the non-resonant antenna, so if you take the non-resonant antenna, okay, in non-resonant antenna, so you will get only the unidirectional pattern. Okay, so this is the major advantage. So in non-resonant antenna, you will get unidirectional pattern. Okay. So next, other coming to the other definitions. So this is a resonant, and here it is non-resonant. So these are not in non-resonant antenna. These are not terminated with. These are not terminated with. These are not terminated with impedance, characteristic impedance of antenna. Whereas here, the fourth point, these are terminated with. These are terminated with characteristic impedance. Characteristic impedance. Okay. So we have seen that in resonant bidirectional pattern, here unidirectional. So due to this, the directivity, gain, and bandwidth is less here, whereas here directivity, gain, bandwidth are more. Okay. So these antennas are also called as periodic antennas. These antennas are also called as periodic antennas, whereas these antennas are called as non-periodic antennas. These antennas are called as non-periodic antennas. Okay. So next, so these are used for fixed frequency application. Fixed frequency application. Fixed frequency application. Whereas non-resonant antennas are used for broadband applications. Broadband applications. Broadband applications. Okay. And eighth one. So examples of this resonant antenna is simple general dipole antenna. Whereas non-resonant antenna, the examples are, so all our practical antennas like horn antenna, or parabolic antenna, lens antenna, all these antennas comes under non-resonant antennas. Okay, so these are the basic differences. Okay, so here in resonant antenna, we will find both incident wave and incident wave and incident wave and standing wave, whereas here we will find only the traveling. Okay, so this is the basic difference between resonant antenna and non-resonant antennas.